Hey friends, I'm Scott Hanselman and I'm here at the Caribbean Developers Conference. We're talking to Intelipark. This is some really cool stuff. They built all this great stuff with Visual Studio and web technologies and Arduino technologies. I'm talking with Eduardo. I'm loving this screen. This is a beautiful screen. This is telling me how many parking spaces there are available?
Yeah, this is a device that tells the user as soon as it enters to a parking lot where to go. Because if you go to some place and you're struggling because everyone is occupying the parking, you don't know where to go. So as soon as you have some options and you see a guidance, then you go to that option. The thing is, this display presents the user with information, basic information about how many free spots are in a area.
Mm-hmm. And what's cool about this is that I've seen things like this at an airport where every single spot has a sensor. And I always wondered, this must cost millions of dollars to do this kind of technology.
Yeah, that kind of technology requires that each spot utilize a sensor, and this could be harmful in the pocket. So our technology uses a technique. We try to measure how many cars enters to the parking through an entry, and how many cars go out from the parking.
And these are the sensors right here. Can we make a car come and go? How do I tell the car is going?
As soon the cars enters to the park, as the car is metal.
Yeah.
So
piece of metal.
Yes.
So you can see the sensor here, how the LED turn on, depending on the spot. But the thing is,
so if metal goes past this.
Yeah, this detects only metal.
Oh.
So you need to have a large amount of metal.
Yeah.
The change.
Exactly.
The change.
You need a large amount of metal in order to modify the reading of the sensor. So as soon as you enter, the detector senses you as a car, and after that I can read that difference in number. I mean, if at the beginning I had about 8 cars and you go out, then I have 7 cars, one less. So that calculation go through this Raspberry Pi that has this shield. This shield is made by us and has 2 modules. Each one is a LoRa module. LoRa from long range. So I can transmit data about 700 meters.
Okay, very far, very reliable transmission.
Exactly.
Not Wi-Fi.
Not Wi-Fi. We use low frequency bandwidth, about 433 megahertz, so we can bypass a lot of obstacles. And because of that, the client doesn't need to do an installation, a physical installation of tubing and plumbing or maybe cabling of data. So you just need to put it a name, an ID, and power up.
That's amazing. And you've got one of the things that's great here at the Caribbean Dev Conference that people can come and see this. And if we can get a camera shot over here real quick, what I love about this is that you've shown us your prototypes.
Yes.
So these are like, hey, I have an idea, I'm going to make it myself, and I'm going to make it with off-the-shelf parts and bug fixes and breadboards, and then that's the first concept.
We burn out about 20 of them.
20 of these, and then you go all the way to scale to have like
a final product.
Fresh, professional final product that we can then see live running here, and it's been running during the whole conference.
Correct.
And then this wonderful Intelipark.io dashboard that's running here in web technologies, and it's showing the different spots, how many spots are available, and interior, exterior. It's a complete system.
Correct. This Raspberry Pi, as the main hub, is a concentrator of every devices. I mean, you can have as many entries, exits installed wirelessly and as many displays installed wirelessly, and all those devices coordinates inside the hub, the Raspberry Pi, and the Raspberry Pi submits the final number here and submits the final data to the dashboard. So at the end, the user or the operator can see the whole status of his facility.
Fantastic.
And you can see, as you can see, a graphic chart that tells you how many spots, how many cars, and how is the traffic
over time.
Over time, yes. Correct.
Yeah. And what I love also about this, just as we stop and we close, because I can hear people are leaving, that this was a 3D printed case using PLA.
Correct.
It's water resistant.
Everything.
It's a beautiful case. Look at that.
You can see this.
That's perfect. You actually 3D printed the screw. Look at that, the threading itself. This is, as a 3D printer myself, this is beautiful work, beautiful design. You can tell it's extremely sturdy and a very genius design. And then you also have the shield that you did custom, and the work was done in C and C using Visual Studio to talk to these embedded devices.
Correct.
Fantastic. So people can check this out, Intelipark.
Intelipark.io. Correct.
All right, we're having all kinds of fun here at the Caribbean Developers Conference, and I'm learning all about Intelipark.io.
Thanks.
Hey everybody, my name is Cecil Phillip, and right now we're at the Caribbean Developers Conference in Punta Cana, and we're checking out some of the contestants from the IoT Challenge. So I'm going to talk to somebody from Agro 360, and they're going to tell us a little bit about what their product does. So how you doing, my friend?
I'm doing great, thank you, and you?
I'm doing pretty good. Why don't you tell us a little bit about yourself, and also tell us about Agro 360.
Okay, I'm Eddie Alvarado, I'm part of Agro 360. Agro 360 is a system that allows the early detection of diseases in crops, identifying the stage of the disease and providing recommendations to the farmers to take actions when the diseases appear.
That's interesting. How did you decide to solve this problem?
It's interesting. It all started when I met the love of my life, which is my wife right now.
Yeah, okay.
When we first met, we started going out, and that moment that happens in our relationship, let's go to meet the family. So when I went to meet the family, she's from a community called Pueblo Viejo in Azua. It's a rural community here in the south region of Dominican Republic. Being there, I saw how year after year, many of the farmers lost their crops as a consequence of the diseases that affect their crops.
Got it.
Specifically, the late blight disease, which is a disease that affects the tomato crop.
Okay.
So being there and with the knowledge that I had in data analysis and artificial intelligence, I decided to take action and build something to help them to fight this problem.
Sure. And so I just want to get an understanding of the severity of the problem, right? Because everybody has crops, right? But how important is the farming industry here to the folks in the Dominican Republic?
Okay. As right now, based on a paper published by the Food and Agricultural Organization of the United Nations, between 25 to 40% of the food production worldwide is lost because of the diseases that affect the crops. And as a consequence of this, as much as 800 million people worldwide suffer of chronic hunger.
Got it.
Yes.
Got it. All right, so tell me a little bit about Agro 360 and how do you actually solve the problem of detecting these diseases?
Yes, we have IoT sensors that we deploy in the farms. These sensors measure the environmental conditions. That data is sent to our weather station that measure other conditions as sunlight, atmospheric pressure, and humidity in the air. And that data is sent to our server, where a system using artificial intelligence correlate the variances in the environmental conditions with those conditions that where the diseases appear.
Right.
Through that, the system creates alerts telling the farmer what to do to prevent the appearance of the diseases.
Got it. So let's take a look at the hardware a little bit. So is this your sensor? Is this what you put into the crop in the area?
These sensors are deployed in the farm.
Okay.
This one is deployed in the farm also, but it's on the central area.
Got it. Okay.
This one serves as a hub. So all the sensors, they connect wirelessly to the hub, and then the information is sent to our server.
Got it. Okay. Awesome. And so what kind of devices are here? Are these like little Arduino devices?
Yes.
Or?
It's based on Arduino. It's ESP12.
Yeah.
We designed how the hardware works, and we created the code, and then we implement the technology.
Sure. Okay. So we have this little Arduino box that's here, right? And then it looks like, in addition to the box, there's also a wire that's into the earth, right?
Yes.
And so I'm guessing this needs to be close to the root of the actual plant.
This is deployed on the farm.
Yeah.
Let's say, in order to analyze the condition of 5 acres farm, which is 30 tareas, which is the measure that we use here in Dominican Republic.
Sure.
We need 4 of these sensors and 1 weather station. We deploy these sensors in different areas in the farm to cover basically a square.
Sure.
And then that information is sent to our server.
Got it. Okay. Sure. So talk to me a little bit about the server. Like, what did you kind of build this stuff on? Like, what kind of technology did you use?
Okay, as to build the model, we use ML.NET.
Oh, did you?
Yeah, it's a Microsoft technology, and we have everything hosted on Azure. Okay. In order to create the data sets for the system, we take all the knowledge of my agricultural engineer in that specific disease or crop, and we curate the data use Microsoft R.
Okay.
After that, we build the model. We put everything together.
Sure. Are you using like anything like Azure IoT Hub or anything like that to like communicate with these devices?
As right now, we start using IoT Hub to be able to get the real-time data from the sensors.
Nice.
Because it's very important to have real-time data because that's where is the value to be able to prevent the disease.
Sure. How do your farmers and like folks in agriculture like interact with your system? Like, do they have an app or a website that they sign into and start to pay attention to like some of these data points?
Yes, they could log into the site.
Okay.
Or they could use the app that I have it right here.
So they have the option. They could do either or, right? I could do the app, or I could look at the website.
Yes. So based in the farm, they receive the conditions of the farm.
Sure.
Also, they receive advices or alerts based on those conditions.
Yeah.
Also, if the farm detects some anomaly in the leaf, we have a machine vision model that the farmer could use to know which disease the plant has.
Oh, okay.
If you want me, I can show it to you.
Yeah, sure. We can step over here a little bit. So on this machine now, this one has like the vision, the intelligent vision algorithm.
Yes.
That's going to be able to detect like, I guess, different pictures that you're going to upload?
Yes. Yeah. No, everything is processed on the Azure servers. What I'm going to do right now, I'm going to show the system 2 different pictures.
Got it.
One of a good tomato leaf.
Yeah.
And then the system tells me that it's hoja sana, which means good leaf.
Yeah.
And then if I go down and show the system a leaf that has a disease, then it tells me that it is infected by Tizón tardío, which is the late blight disease.
Got it.
To this, we help farmers identify the disease and take action.
Okay, that's great. How many different types of diseases does your system detect?
As right now, we start working with the tomato, which is the #1 fruit grow worldwide because of the consumption fresh, all the sausage that I make, ketchup and everything. It's a very important crop.
Yeah.
And we start working with a company called Fongamundi. They are one of the main rice producers in Dominican Republic.
Yeah.
And we start deploying the system in 1,500 farms, rice farms in Dominican Republic.
Oh wow, that's great.
And the most interesting of this is that those farms are small scale farm of poor local farmers. Fongamundi is sponsoring the technology for them.
Sure. So if I'm a farmer, right, and I want to implement something like this into my farm, like how easy is it for me to can I just call you on the phone and then you'll send like a group of folks from your team to come and now you'll just like instrument my lands with like IoT data?
It's basically how it works. The farmer could contact us directly, and what we do is that in different communities we identify youth, unemployed, and we train them on how to install and monitor the farm using Agro 360. Okay. Those youth are the one that helps the farmer install the sensors, and they visit the farmer every other day to make sure that everything works correctly. So with Agro 360, not only we are giving hope to the farmers, but we are creating new job opportunity in rural areas for those kids.
Nice. So I want to tell me about the last piece of it. So I have the system, right? You're identifying different types of diseases in my crops. what do I do now? Like, do I take this information and go, I don't know, purchase certain pesticides or treatments for my plants, or does your company do anything further with that information and that data that you collect?
What we do is that based on the confirmation of the data, we give the recommendation of which agrochemical to use if it is needed.
Got it.
That's basically what we do.
Cool, awesome. Well, this sounds great, man. Well, thank you so much, man. This has been great.
Thank you, a pleasure.
And this is Agro 360, and they're one of the contestants here in the IoT Challenge here at the Caribbean Developers Conference.
Thank you.
Hey friends, I'm Scott Hanselman. I'm here at the CDC, the Caribbean Developers Conference in the Dominican Republic. I'm talking to Christopher and Eladio about iBin. This is super cool. I'm really impressed with this solution here. So I'm looking at our trash cans.
Yeah.
They're tiny trash cans, but let's imagine they can be any size, yes?
Yes.
Okay, and why are these special? Why are they special?
Well, basically, these trash containers are constantly measuring the trash level inside it. So with that, we can have in real time data from all the containers on the trash level.
Okay, so if I imagine, like right now we're at a resort in Punta Cana and it's huge and it's got trash everywhere, I assume they just check them all every day.
Yeah, so you don't have to check all the trash cans to see if they are full or not. You are going to get to a specific full containers, so you can make more efficient the collection.
Right, because if I'm collecting every trash every day, I'm wasting time and energy.
Yeah, for example, you can have containers that you need to wait days to get full, and others that every day get full. So with that, you can control it.
This is really cool. So behind it, we can see little chips, if you can look at the chips right there. So this is a prototype that you made as part of this hackathon. You're both students, right, in university.
Yeah.
And this is real. It really works. Can we make some trash?
Yeah, for sure.
All right, you have some trash for me?
I can.
All right. Okay, we're putting in some trash. Okay. So now our trash can is somewhat full. And then we've got this containers list, and this is in ASP.NET, in Azure Hub.
Yeah, Azure Event Hub and Azure Stream Analytics and all those things to control the events.
That's cool. And when we started out, we had 3 trash cans.
Yeah.
And now look, it's just updated. See that? So now container 3 is quite full now. It's 70% full. And this is in the west zone. So if I have many hundreds of trash cans in different zones, how do I decide which trash can to go to in what order?
Yeah. We are now working with the specific collectors by zones. For example, I have collectors that will go to east zone and west zone. So we are going to run an algorithm that will find the best route based on the zone. So for each zone, I have, for example, 3 collectors. These 3 collectors will have divided all the containers that are in the zone. Mm-hmm. And it will run the algorithm traveling salesman to find the best route and the shortest route to collect these containers. And it will assign one route to one collector. So they will have different containers and different routes. So the route is going to be the shortest one for each one.
That's cool. So let's see if we look at a map. So here on the map, we can actually see the containers. And then we've got,
here.
There's a container, and
the other
there's a
one,
container over there,
one.
and then there's one a little bit farther down.
Yeah.
So then you can go and plug it into Bing Maps or Google Maps and tell the person, okay, you are the recycling guy. Go here, here, here. You are the trash guy. Go here, here, here.
Yeah, we're supposed to provide that maybe in an application or something to give the specific user or collector their route. So they will just have to open it and they will see what they have to do.
It's like Uber for trash, and they know exactly what to do.
Yeah, but with specific collectors, nobody will say oh, I want to collect garbage from the.
we can crowdsource our garbage and just have everybody pick it up.
Yeah.
Everybody wins. This is a really cool idea. So you made all of this as a hackathon, and now do you think maybe you'll make a company?
Yeah, we have been receiving feedback throughout the day. So we're seeing that we have potential to fix things as they're working now. And yeah, we started this like a hackathon to participate here, and now we're looking forward to making it more serious and having something solid.
This is really cool, and what I love about this is that it works with any trash can of any size.
Yeah.
These are just prototypes, but you can plug it in and have a device stuck to the top of a dumpster or a small
Exactly.
or big.
If
Fantastic.
it's, for example, a bigger container, we will have more sensors to have a precise estimate of the garbage level.
That's cool. You're solving real problems. I appreciate you both. Thank you very much. Christopher and Eladio, we're here at CDC having a great time making new products.